Okay, YouTube, in my last 3 videos, we've been discussing different transformations of functions and how we write them in general. What I'd like to do is actually take a look at an example of when we'd use some modeling with math here, where transformations would actually come into play and how we would necessarily interpret those. So let's go ahead and consider this example here. It says we make cards to sell, and our revenue is represented by this function f of x equals 3x. And it says that our profit now is $15 more than 60% of the revenue for hex cards. So when we look at this revenue model here, we could look at it this way. We say f of x is our revenue. So we say f of x. And this is our revenue here. Okay. And when you talk about revenue for a business, let me get that out of there. Revenue. That's like every dollar you earn before you pay your bills. And then x is going to represent actually the number of cards that we sell. Okay. Profit is a little bit different than revenue. I will tell you that the profit, see, it depends upon your revenue. So this is how these two functions are going to be related. But profit's kind of like after you pay your bills, what you actually get to keep after that. So you'll notice that there's a relationship between our revenue function here, which says, well, we're going to take 3 times the number of cards. That's what we get in terms of revenue. And our profit is actually $15 more than only 60% of the revenue of the cards that we sell if we sell X cards. So the question really becomes, so what's our profit going to be at 200 cards here? Now this sounds really confusing, but I'll tell you what, let's just go ahead and start with what we know here. We know that revenue is everything we make. Revenue is what we make, what we earn. Okay. Profit is really just revenue minus like expenses. Okay. Expenses. Very hard to write with this stylus here. So let's go through these steps that I've written out here, and I'll kind of talk about how we piece this together. But it says we were given a function to represent our revenue. This is this 3 times the number of cards is our revenue. And then we're given a verbal statement that tells how our profit actually relates to that revenue. So what we're being, asked to do here is find out the profit for 200 cards. What we're going to need is a profit equation, essentially, okay? So putting this together, we need to understand the problem first. Let's come up with a plan. So it says, let's go ahead and write a function p that's going to represent our profit, since that's what we're trying to find. And then we're going to use this function to find the profit for 200 cards, okay? So in terms of how we're going to come up with a profit equation, really, we already have been told what our profit equation should be. What we do a lot of the time in algebra is come up with equations from a verbal statement. So this verbal statement, let's go ahead and interpret this, but it says our profit is $15 more than 60% of our revenue. So you'll notice I've kind of already written this out here, but we say profit is. When you hear the word is, we really are talking about an equal sign here. And $15 more than, we'll consider what $15 more than might be. We say $15 more than would be 15 plus, okay? More than is more than here. So we say 15 more than, and 15 more than what? Now, 60% of the revenue for X cards. We say, all right, well, I have an expression for revenue up top. We'll get to that here in a second, but basically 60% of the revenue. This word of is quite important here, because when you hear the word of in math, for the most part, I could say that you could think of it as grouping, and that means multiplication. If I had 2 of 8, I would have 16, or 2 times 8. So when you look at this here, really what we're doing is we basically took that verbal model, and we wrote a plan. We said, well, our profit is 60% of our revenue, and it's $15 more than that. That's how we're going to calculate our profit. All I've done from this step really to this step is take this verbal model, taken it, and kind of abbreviated things here. So our profit, we're going to use the letter P to represent that. 60%. Recall that when you write a percentage as a decimal, we move that decimal back twice. So we get 0.60 is 60%. And then remember, multiplication and of are kind of have an equivalency there. So 60% of our revenue plus 15, that's going to be our profit here. And that's going to be our profit really equation. Okay. So another way to look at this would be able to say, well, their profit for X number of cards is 60% of our revenue, and our revenue was given by this f of x up here. So 60% of f of x plus 15, this is really what our profit equation is going to look like. So when we do our substitution, we've been talking about combinations of functions here. Really, I can start to look at this as, well, it's really just our revenue equation. I notice that it's going to be shifted up 15 in terms of its graph. It's a vertical translation by 15. And since we're multiplying by 0.6, it's going to be vertically shrunken by a factor of 0.6 here. So I am going to finish this up by writing out this profit equation again, but substituting f of x in there since we know it. And f of x, recall, is just this 3 times x, where x is the number of cards. We get this. So our profit equation really looks like this here. We say 0.6 times, I should say this, 0.6 times 3 is going to be 1.8. We have 1.8x plus 15, and this is going to be our profit equation. So we have profit equation, and we have a revenue equation, which was f of x equals 3x, okay? That's in there as well. So my question is, how do the graphs of the two functions, revenue and profit, compare to one another, and interpret why this might be the case? So what I intend to do is just hop over to either a graphing calculator, or in this case, since we have Desmos available to us, it would be very, very quick to use that as a tool just to kind of visually investigate this. So we have, going to Desmos, f of x, this is our revenue equation. We have 3 times the number of cards. And the very, very first thing I want to do here is, because we're trying to answer this question, how much we're going to make at 200 cards, I'm going to go up here to graph settings, and you'll notice that it says x-axis and y-axis. I'm going to add a label. And I'm going to say, well, x-axis represents our cards. You can see that that shows up down here. And we'd say that we have here either profit or revenue. So we're going to say, I'm just going to say functions of x. We have 2 functions of x that are going to go on this axis. In terms of the x-axis, I'm going to say, well, we're starting at 0 cards probably. And since we're going out to 200 cards at least, how about we go to 300 cards? And in terms of what size steps we want to take, I think going by 50s might not be that bad of an idea. So you see that, I kind of moved it already, but it goes from 0 out to 300. There we go. And it's going by 50s, okay? Next, we say, well, what's our profit going to look like here? Well, I already know this. I mean, if it's 3 times the number of cards is our revenue, and we sell, say, 300 cards, 3 times 300 would be 900. So I'm going to at least start at $0, and I'm going to go up to 900. And these are being measured in dollars. Actually, I just changed the x-axis again. Forgive me here. We went 0 to 300. We need to change the y-axis. The y-axis will start at $0, and we'll go up to at least $900 here. And we say functions of x, we're going to measure this in dollars. All right, so now looking at this, I'm going to zoom out just a little bit here. You can see that our revenue equation is increasing, and it's increasing at a rate of $3 per card. When we now go up here and we say, well, let's put in our profit equation, we were able to get this as a combination of transformations to our original profit equation, or revenue equation. So we said it's 60% of that plus 15. What that came out to be, and we could say that it's, we could even write it this way, 60% of f of x plus 15. And what I want you to see is I'm going to write p of x again with what we had come up with, which was 1.8x plus 15. And I just need you to see that they're the same thing. I mean, they overlap. So when I turn this blue graph off, you can see you get the same thing here. So what I wanted to do were answer 2 questions here. The first question that we were trying to answer really is this. We're asked to find the profit when we get 200 cards sold. So one way to do this, the simple way to do it is to say, well, we've got an equation. You guys, all we really need to do is say, well, what would our profit be if we were to plug in 200 cards? And we can see that we get 1.8 times the input plus 15. We're just going to evaluate this for 200. And I'll get my calculator rocking here. I'll go ahead and quit out of the graph mode here. I'm going to turn it on. So quit. And we have 1.8 200s. And that was plus 15. And I see here that we get $375. So I'm going to go ahead and write that down. $375, okay? But does the graph support this? So when we go look at the graph here, remember this green function here is actually our profit equation. It's a little bit less than our revenue. And one question to start considering is, well, why is our graph of the green graph here, our profit, growing more slowly than the revenue equation? But let's go ahead and take a look here. When we sell 200 cards, we can trace this up here, and I'll try to put my cursor right on it. Yeah, right there. 200 cards, our profit would be $375, which, as a matter of fact, is much less than our revenue. Our revenue would have been 600. We just don't get to keep all that 600. So why don't we get to keep all of that 600 there? And that's really the question that we need to finish up with here last. But essentially, how do these 2 functions, revenue and profit, compare to one another? We could say that profit is less than our revenue. That's one thing. I also noticed that when we look at our graph of profit, we actually start up higher. We start at 15 before we've even sold a card, whereas revenue starts down at 0. That's an interesting thing to note. Okay. And why is it the case that our profit is less than our revenue? You know, we might say something to the effect that our profit really, you know, we could scribble this down here, we should, but my handwriting's just bad. Our profit is less than the revenue because we only get to keep 60% of our revenue plus $15 that we started with initially, okay? But that's how we could look at an application situation, modeling with math here, when we're talking about combinations of transformations of a function. Cheers.